Hello everyone, hope you guys are doing well. In this video I will do the solution of the test that we had recently. Your test that included atomic structure, states of matter, and electronic configuration. Okay, so in here we had the periodic table, ion names, and then now we're moving on into the questions. So in the first one, you guys can see that the picture is not very well structured. With structured, I meant like all the particles had to be in a structured way, so we could call it a solid state. Okay, but because it's not structured, it goes kind of random. Okay, there are some empty spaces, and it's not in a structured shape. We know that this is a liquid state. Okay, and then the one on the right is obviously a gas state where we have a lot more space, so this is gas state or gaseous state. And question number 2, there is a coffee, mouthwash, vinegar. If you actually check them out, all coffee, mouthwash, and vinegar, we can't see any visible differences or characteristics for us to call this a heterogeneous mixture. Heterogeneous mixture. Heterogeneous mixture are such as like oil and water. This is a heterogeneous mixture where we can visibly see the difference. If we fill it in a cup, we'll see water in the bottom and oil on the top. Okay, but these guys, you can't really see them, so that's why it's homogeneous mixture, and the answer is true. A third question. Look at the diagram below, determine what does it represent. As you guys can see, this one in here is a one compound. Compound A. And this guy with the white stuff on the right is compound B. And we have 2 of the A and 2 of the B, so it's a mixture of 2 compounds. Okay, now we're gonna go into the next question. It's asking identify an atom with the smallest number of neutrons. So first of all, we need to find the atomic number of all these guys in here. So calcium, we got calcium, iron, copper, and sodium. If you look into here, atomic number on the periodic table is shown on the top. So sodium got 11, calcium got 20. Okay, the value in the bottom is atomic mass, but these are atomic number, which is the number of protons. Atomic number 20, and then we got copper. Where is the copper? Is 29. And then we got iron, which is 26. Okay, now we go down in here. So we're gonna put into sodium, we're gonna put 11. And for copper, we got 29. This is 26. And calcium is 20. So neutron number is number of neutrons equals to atomic mass minus proton number or atomic number. Okay, so for calcium, it is the neutron number is gonna be 40 minus 20 is 20. For iron, it is 56 minus 26, it is 30. And for copper, it is 64 minus 29, it is 35. And for sodium, it is 23 minus 11, which is 12. And we're looking for the smallest number, which is this guy. That's why the answer is D. Okay, so now in here it's asking choose the correct options. Fractional distillation used to separate liquids with closer boiling points. If you check my notes, you will see that if we have temperature of boiling point differences, so for example, water and alcohol. The boiling point of water is 100 degrees and the alcohol is 78 degrees. Their boiling point difference is 100 minus 78, which is 22 degrees Celsius. Because this is less than 50 degrees Celsius, we're going to use fractional distillation. Okay, so that's why the answer is right. Closer boiling points. Simple distillation is used to separate liquids with boiling point gaps of at least 50 degrees. That is right as well. We said that if the boiling point difference is greater than 50 degrees, such as, let's say, salt and water, we're going to use simple distillation. Okay, simple distillation, which is this guy. If you check the notes on this separation methods, you will see all the information I mentioned. Filtration is used to separate mixture of alcohol with water. As you know, if I have a filter paper and I'll try to pass it through the funnel, I'll put alcohol and water into here. Both alcohol and water is going to come out. Okay, it's going to be the same. Like I won't be able to filter it out. I will be able to filter out, for example, sand and water, because sand will get stuck on the filter paper. That's how I will separate sand from water. Okay, that's why this answer is wrong. Separating funnel is used for separation of sand with sugar. So sand and sugar, imagine this. We have discussed it in a class. If I have sand with sugar, two solid particles, you can't separate this stuff. For us to be able to separate it, I'm going to show you a way to separate them. But just using separating funnel, like think about this, is that like you have separating funnel looks like this, okay? And then you can use separating funnel to separate water and oil, but two solids together, you can't use separating funnel. You need to do a couple of steps in order to do separation. So that's why this answer is wrong, and our answers are 1 and 2. Okay, so now into the 6th question. So it's asking, first of all, what is combustion? Combustion reaction is the one that I'm just gonna say here, adding oxygen, O2, and getting products of CO2 and water. Okay, so in here, combustion is like burning, right? Burning. It's burning. How do you burn? Using the oxygen in the air. So in here we had the C2H6 ethane that we burned using oxygen, and we got the carbon dioxide and water as a product, as I mentioned up in here. Okay, so that's why this is B. And then here, combination. Combination is when we have two reactants combining together and making one product. That's why it is C. Decomposition is when we have one component separating into two different chemicals. So that's why this is D. And then single replacement is this guy, because as you can see, this guy hits hydrogen, kicks him out, and make a single replacement. That's why this one is A. But in here, for this one, as you can see, sodium exchange place with barium. So sodium grabbed chlorine and barium grabbed sulfate. So this is double replacement. But we left it for purpose to see if you guys are gonna recognize it. You didn't have to fill this one in because we don't have any choice for this one. But even if you did, write that this is double replacement, I didn't cut any points. Okay, so now question 7. We're on question 7. It's asking, below are listed compounds with the corresponding names. Identify the correct naming lines. So if you go up in here, the ions, we have ions, ammonium ion, it's NH4 plus, and then we have phosphate ion, which is PO4 negative 3, and then we have carbonate ion, CO3 minus 2, and then we're gonna using those, we're gonna decide, and there's one more, hydroxide ion is OH negative 1. Okay, so using that information, let's see. So this is sodium hydroxide. Okay, this is good. And then we have lithium nitrate. As I told you, nitrate is NO3 minus negative 1. So this is one of the answers. And then we have aluminum hydroxide. So this is good. But in here it's shown that phosphonate. This phosphonate is PO3 negative 3. But this one is 4. So that's why this is wrong. And then we have magnesium carbonate, which is right. And then sodium sulfate, which is right as well. So this is 2. And then we have ammonium nitrate, but it's shown as carbonate. So this is wrong. And we have calcium carbonate, but it's shown as nitrate. So this is wrong as well. So that's why the answers are 2 and 4. Okay, so we're going into some serious stuff in here. Question 8. So this is, I have seen a lot of you students made some mistakes. So my dear students, I'm gonna explain this again. So please be careful. Grab pen and paper when I write this. So we're gonna do it together. So before I write the electronic configuration, I need to look the atomic number. Atomic number is definition of an atom. Okay, so using that atomic number, we're gonna find what's the symbol. So 25. Now we go to periodic table. We're gonna look which one is 25. So we go this 23, 24. 25. So what's this element? Is manganese. Okay, Mn. Now we go back in here. So the identify element of Y plus ion. So the element Y or Y plus doesn't matter. This element is manganese. Okay, that was the answer for this question. Now we go into electronic configuration. So we got manganese with 25 atomic number. We always use atomic number for electronic configuration. Okay, so if we have 0 charge on this guy, because we know that it is 0 because there's nothing given, right? So we have 0 charge. If there's nothing given, we know that it's a 0 charge. Then we have atomic number. Atomic number meaning proton number will equal electron number. So now we have 25 electrons. We know that for element, we'll write proton number in here, neutron number in the middle, atomic mass on top, and electron number in here, and this is where we have charge. Okay, if it's plus or minus. Okay, this is the stuff. So right now let's write this down. Atomic number 25. So once you learn how to write 1s2, we need to know that 1s comes first. Let's write this together. 3s, 4s, 5s, 6s, 7s. And then we get 2p, 3p, 4p, 6p, sorry. Got 5p, 6p, 3d, 4d, 5d, 6d, and then we got 4f and 5f. This is the cheat sheet, the sheet that you need to memorize. And then in the exam you will use this. Okay, so we start with 1s. We know that s orbital got 2 electrons, so 1s2. And then the next thing comes is this guy, 2s2. And then we have 2p6 and 3s2. So 2p, we know that p got 6 electrons. And then we got 3s2. And then we have, so before we continue, let's count the number of electrons. I got 2 plus 2 plus 6, which is 10 electrons. So we have now 15 left. And then we go 3s2, and then next we have 3p6, 3p6, and then 4s2. This is another 10 electrons. And then we got 3d5. Okay, so 3d5. Now all together this is adding up to 10 plus 10 plus 5 is 15. So electronic configuration of manganese is this. This was the answer that I was expecting. Okay, so now we go into deducing the electronic configuration of Y plus 7. So before I move on, guys, because I know when I have a X element, for example, and I got for example P number of protons, right? If I have a 0 charge, my electron number is going to be still P. Okay, but if I have plus charge and negative charge, the electron number changes. And how it changes, I'm going to show you. For example, let's say manganese had 25 protons, and let's say 22 electrons. Okay, we don't know what's the charge. Let's find it. So proton has a charge of +1. Okay, electron has a charge of -1. This is a definition. Protons are always positive. Electron is negative. And neutron, we know that neutron has no charge. It's neutral. Okay, that's where the name comes. So 25, let's calculate the charge of this guy. 25 times +1, the number of protons, plus 22 number of electrons, and this adds up, 25 minus 22 adds up to +3. That's why the charge of this guy is +3. Okay, so now we're given that manganese have 25 protons. We know that because its atomic number is 25, and it has +7 charge. Now it's asking the electron numbers. That's the question. And then we need to write the electronic configuration of that. So 25 times +1, and then we don't know how many times. Let's say E times -1 adds up to 7. So 25 minus E equals to 7. And then we got E equals to 25 minus 7 is 18. Okay? So from here we know that positive charge means we, I'm gonna write it with big letters, we lose electron. Negative charge means we gained electron. So now we're given to us that 7 electrons are lost, right? We lost 7 electrons because we know that the charge is plus 7. So let's look at the electronic configuration of manganese. This is 25 electrons, right? Now we need to lose 7 electrons. 18 electrons are going to be left. We always lose, this is one more rule, we lose or gain electron in last shells or subshells. Okay, so where do we have last 7 electrons? If you count it, you're going to see that this 2 and 5, they add up to 7. So let's say we lose this, guys. What are we going to left with? The manganese plus 7, manganese 25 plus 7 is going to look like this. 1s2, 2s2, 2p6, 3s2, 3p6. And that's it. You see, we lost those 7 electrons, which are these guys, and then we left with these ones. Okay, so that's the answer for this section. So this is my answer. We always lose electron in last shells and subshells. Okay, now we move on to the question 9. It's telling us that carbon has 2 naturally occurring isotopes in the nature. In a case study, relative atomic mass of carbon was found to be 12.10 AMU. Calculate the percentage abundance of carbon-12. Okay, so if you guys remember, I told you that I multiply atomic mass of first isotope plus atomic mass of second isotopes by their abundance. So abundance 1 times abundance 2, and then I divide abundance 1 plus abundance 2, and this is gonna give me, once I divide everything by 1 AMU, which is 1 atomic mass unit, I get the value of relative atomic mass. So using this formula, I can find it. But I know that because there are two compounds, my x plus y is gonna give me 100 because there are only two isotopes. Sorry, I meant to say isotopes, not compounds. So 2 isotopes, they need to add up to 100. Even if I had 3 isotopes, they should have added up to 100. Okay, add up to 100. So now let's do the calculation. So atomic mass of the first one is 12. The other one is 13. Okay, so 12 multiplied by, what's the percentage? X. 12x plus 13 atomic mass, you see this guy, 13, multiply by y. Okay, y. Divided by x plus y gives you 12.10. Okay, 12.10. And because you know that x plus y is 100, we could say from here y equals to 100 minus x, right? So, and x plus y, this is going to be 100, so 12x plus 13 times 100 minus x. So instead of y, we put this. And then x plus y is 100, so we're going to put 100 in the bottom. This is going to give us 12.10. And then we solve it further. 12x plus 1300 minus 13x gives us 1210. Okay, and then you do the math. Now it becomes 1300 minus x becomes 1210. And then from here, x is 90. And then y becomes 10%. So 90% and 10%. Okay, this is the answer for this question. So now we move on to the next question, question number 10. So we got it says that below is given number of protons of a neutral element. So this guy has no charge, and we have the proton number given 24. Proton number is atomic number. Atomic number is proton number. So let's go back and find the 24 proton number, atomic number. So 24 is giving us this guy, chromium. Okay, so let's go back. So chromium, now I have chrome with 24 atomic number. Indicate element symbol. There you go. This is the answer for this one. You could say chromium, or you could just write chrome. It doesn't matter. I will still accept points. Okay, now you see over here A, B, C, D. This A stands for first shell, B stands for second shell, C stands for third, and D stands for fourth shell. Okay, so this 1 and 2, 3, 4 are the values. Do you guys remember? I said I had 1s and 2s. This 1, 2, 3, they are like all these numbers are my shell numbers. But the S or P shows my subshell. Okay, this is my subshells. These are my shells. So now I have here first shell, I got 1, second shell 2, 3, 4. Okay, now it's asking us to find the number of electrons that are located in each energetic level. Energetic level is the shell number. So now let's write this down using this formula. Now I got 1s2, 2s2, 2p6, 3s2, 3p6. Okay, we're going to use this. Now we're going to write it down. So chrome electronic configuration, it has 0 charge, so we got 24 electrons. So it is 1s2, 2s2, 2p6. Now we got 10 covered. We got 14 more to go. So 3s2, 3p6. So 18 got covered. Now we got 6 electrons left. And then the next 6 will be 4s1 and 3d5. As you guys can see over here, like I could have done 4s2 and 3d4, but this is wrong. I told you the chrome and copper are exceptions in the class. Okay, chrome is always 4s1 3d5, and then copper is going to be ending up with 4s1 and 3d10. It's just this is a stable version. This is quantum mechanics. I can't explain you even further because of the limits we had for your course in the university. You will discuss it, but this is stable rather than this. This one is unstable, the one I crossed out. Unstable. That's why we're going to keep this one. So now let's fill the numbers. So I said A is 1, B is 2, C is 3, D is 4. So now if you look in the fourth shell, how many electrons do I have? Just one. So this one goes in here. And in the third shell, how many electrons do I have? Third is this guy, and this guy. So we've got 2, 6, and 5. 2 plus 6 plus 5 is what? 13. So this is going to go 13 in here. B is my second shell. So in second shell is 2 in here and 2s. So how many I have? I got 2, 6. So 2 plus 6 is 8. And then for first shell, I only have 2 electrons. If you add them up together, this is going to be 24. Okay? And then over here, we ask you to use mathematical denotations to point it out. So we know that D is the smallest, and then comes A, and then comes B, and then comes C. This is the one I was asking for. I gave you guys partial marks for whoever got some of the stuff right. Okay, so now we move on further. Question 11. Sodium is defined by the symbol of Na. When it reacts with water, hydrogen comes out as one of the products. Using the following information, answer the questions below. Atomic mass of sodium is 23. Indicate number of protons and neutrons. So sodium is denoted like this. We went to periodic table before and we found that sodium got 11 protons. Atomic number is 11. Okay. So we're going to put this in here, 11. Now we want to find the protons and neutrons. So atomic number is 11, so proton number of proton is 11. And the neutron number is going to be 23, atomic mass, minus 11, which is 12. Most of you got this, so good for you guys. Now we're going to the second one. And then in this case, I got sodium with plus 1 charge. I got 11, I got 23. And now, before I move on, because this guy has a 0 charge, it's neutral. There's nothing given to it, so I know it is neutral. So we got 11 electrons in this, okay? So now, do you guys remember I said over here, so this is important stuff, important. So plus charge means we lose electron. So plus charge. So we lost 1 electron. So before we had 11, now we lost 1, now we have 10 electron. Okay? Now it's asking protons, neutrons, and electrons. So proton is still the same. Element never changes its proton numbers. So never change. Electron number changes, but proton number doesn't change. Neutron number, so still is going to be, neutron number is still going to be the same because atomic mass the same and proton number the same, so 23 minus 11 is 12. So never changes either. But the electron number changes. So electron number before was 11, right? But now it is 11 minus 1 because of plus 1 charge. Now we got 10 electron. 10 electron changes. Okay, now question part C. Indicate whether the electron was lost or gained when sodium has plus 1 charge. As we discussed above, plus 1 charge means we lost. Electron was lost. Indicate in which subshell this action happens. Okay, this is the stuff that most of you didn't get. Okay, now let's write sodium neutral. So neutral one is gonna be 1s2, 2s2, 2p6, 3s1. You guys see this? So I got 10 in here, and then 11th electron is in here. Sodium plus 1 is gonna be 1s2, 2s2, 2p6. So I literally lost this electron, okay? That's why now I have 10 electrons. You guys see? Now it's asking in which subshell. So the subshell that we lost it from is 3s, okay? You needed to show me to get the full answer. Not the 3. This is my shell number. Shell number. I'm asking for subshell, which is given with the orbitals. So S or P. So this one is 3s. Okay? Perfect. So question 12. It's asking us to indicate whether the following information is true or false and explain why. So chrome plus 3 ion has 23 electrons and 28 neutrons. So if you guys remember from the question above, for chrome, we got the electronic configuration. Chrome has 24 proton number. And then for zero charge, we got 24 electrons, right? But now chrome plus 3 means that we lost 3 electrons. So 24 minus 3 is 21 electron, okay? And then we know that the atomic mass number is given as 52. So the neutron number is 52 minus 24, it is 28, okay? So here we can see that electron number is wrong, but the neutron number is right. So the whole statement is false, and this is the explanation. Okay, now it's asking deduce the electronic configuration of chrome atom. So chrome atom, we have written it above. It is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is an exception. I'm just gonna write this in terms of boxes. So energy goes up. I got 1s, I got 1 orbital, and then I got 2s, and then 2p, and then I got 3s, 3p, and then I got 4s, and then I have 3d. So 3d, we know that it holds 5 orbitals. So I'm gonna go, actually I'm just gonna erase this stuff and I'm gonna zoom in here to draw this. So now let's do this together. So I got 1s, and then I have 2s. So now, and then I have 2p, and then I got 3s, then 3p, 2p. I know that p orbitals are 3. 3 is only 1 orbital, and then I got 3p. I got 3 orbitals. That's why it holds 6 electrons. And then I got 4s, and then 3d. Okay, now let's fill this in. So 1, 2, 1s2, 2s2, and then we fill this p orbitals like this, and then I go back fill this, and then I go 3s2, and then 3p6, I go fill the other ones, and then I have 4s1, 3d5. So now if you look at here, I got 6 unpaired electron. Unpaired is that we don't have a pair, you see, like this one. So, and we got 18 if you count all of this: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 18 paired electrons. Okay, now we look back into this equation, this question. You can see I just written it over here using the box form, but this one is electronic configuration. Now we're gonna look back. So this is very important too. Important. Okay. So now let's go into the question C, the electronic configuration of chrome plus 6 atom. So chrome plus 6. So we got 24 before. Now I lost 6 electrons, which means 18. 24 minus 6. Now we got 18 electrons. If we look back in here, so this is so far is 10. This is 8. And this is 6. So I lost the 6 electrons. Okay, 6 electrons. Now I have 1s2, look the one up, 2s2, 2p6, I got 10 now, and then 3s2, 3p6. This is my electron configuration for chrome plus 6. I lost my electrons from my last shells. Okay, so now we're gonna go into the next question, which is in here is this guy we have. Do you remember the formula? I had atomic masses, and now I have abundances. So this one is approximately 68, and this one is then this is 32. Okay, so because 68 plus 32 adds up to 100. So now it's asking to find relative atomic mass. Relative atomic mass is atomic mass 1 times abundance 1 plus atomic mass 2, and then abundance 2 divided by abundance 1 plus abundance 2 divided by 1 AMU, atomic mass unit. Atomic mass unit. Check out the PowerPoint, you will see it over there. Okay, this is the definition. And in here, use the data from diagram to calculate relative atomic mass of the given element. So we know that we got 61, this is atomic mass 1, this is atomic mass 2. So 61 times 68 plus 65 times 32 divided by 100 is going to give us approximately 62.24. This is the value of the relative atomic mass. Okay, now identify element using the relative results above. So we need to go back to the table, periodic table in here. We're going to look at atomic masses, which are the ones on the down. So we got nickel, and then we got copper, which is the closest to the answer. So our element is copper. Okay, so we go back and then we say it is copper, or we could just say copper like this. It's asking indicate the electronic configuration of analyzed element. So we know that if we look from periodic table, atomic number of copper is 29. And the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d10. So this is an exception as well. Normally we fill in. So 4s2 3d9 is incorrect. This is unstable. Okay. Okay, now we move on to the 14. It's asking us nitrogen is a chemical element, and over here it's asking to draw the neutral nitrogen using periodic table. So from periodic table, if you look it up, we got atomic number 7 and we got atomic mass number 14. So our neutral number is 14 minus 7, which is 7. So we got in the middle the Bohr model. Bohr model that we're gonna draw. We got 7 protons. Okay, 1, 2, 3, 4, 5, 6, 7. And then we got 7 neutrons. 1, 2, 3, 5, 6, 7 neutrons. And now, okay, now let's write the electronic configuration of nitrogen is 1s2, 2s2, and 2p3. You see 2 plus 2 plus 3. So in the first shell I got 2 electrons. So I drew the first shell and I have 1 and 2 electrons. And then in the second shell I got 5. So my second shell is this one. It is, sorry for the drawing picture, 1, 2, 4, 5 electrons. So this is the, from here you say 7 proton, 7 neutron. Okay, 7 neutrons. This is the answer I was looking for. Now it's asking indicate the electronic configuration of neutral nitrogen atom. I written it below. It's 1s2. I got atomic number 7. It is 1s2, 2s2, and 2p3. Now it's asking draw the shape of each orbital that are involved. We have S and P, and we know that over here S is shown as spherical, and then P is shown as Dumbbell form. Okay, so if you look it up, and we have different type of P's. Okay, so we got, so if it's X, Y, and Z, if it's on X coordinate, this is PX. Okay, but if it's shown as an X and Y, sorry for the drawing, just gonna fix this one. So X and Y and Z in here. If it's shown on Y ordinate, then this is PY. And if it's shown on Z ordinate, it is PZ. So there are 3 orbitals. Each one holds 2 electrons. So S holds 2 electrons, 1 p orbital holds 2. So we're gonna do these shapes. So now it's asking what are molecules made of hydrogen and oxygen atoms, and students that were doing states of matter experiment in the lab measured the thermometer that water started boiling at 90 degrees Celsius in an open beaker. So now it's asking deduce the electronic configuration of both hydrogen and oxygen. If you look up from periodic table, hydrogen has atomic number of 1, oxygen has an atomic number of 8. So if you want to write them down, the electronic configuration of hydrogen becomes 1s1, and then for oxygen I have 1s2, 2s2, and 2p4. Okay, so if you write in the box form, you would see that 1s for this guy, so we have 1 unpaired electron, and then for oxygen I have in here in the energy diagram, so I got 1s and then 2s and then 2p, got 1, 2, 3 orbitals. So I fill it like this, so 1s2, 2s2, and then I go 1, 2, 3, and 4. So eight electrons are left. So over here I have, so I got 2 unpaired, I got 2 unpaired electron and 6 paired electrons. So we can count this 6 paired ones is 1, 2, 3, 4, 5, 6, and then 1 and 2 unpaired electrons. So in the next one, you just need to fill this one in the orbital boxes. So we said that 1s2, 2s2, 2p4. So this is 1s, this is 2s, this is 2p. I fill it like this. So 1, 2, 3, 4, 5, 6, 7, and 8. This is the one that I was expecting from you. And the next one is again 1s, 2s, 2p. Now this time it's asking for O negative 2. I told you guys that negative means that we gained electron. So negative signs. So because we have negative 2 now, because we had 8 electrons before, with negative 2 now I have 10 electrons. So now let's fill this one in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's all full, right? So no unpaired electron. 10 paired electrons. And the last question is asking, according to reference, water was supposed to boil at 100 degrees Celsius. Explain why water started boiling when the temperature reached 90 degrees Celsius. So the main reason is that the thermometer wasn't measuring the temperature at the bottom of the beaker. Some people have written about the composition of water and then the surrounding conditions. I gave partial marks for this stuff, but the main reason is the thermometer wasn't measuring the bottom. It's actually, if you remember, we had bubbles coming from the bottom, meaning that at the bottom we had 100 degrees Celsius, even though our thermometer was showing 90 degrees at here. Okay, so that's it, guys. I hope this helps. I wish you best of luck in your exam.